Most early SaaS products treat billing like a simple, completely binary switch. You know the drill. Paid means access, unpaid means absolutely no access. It sounds super clean in theory, right? Well, welcome to this explainer. Today, we're going to completely shift how you think about SaaS billing architecture. We're moving away from those brittle, simplistic toggles and diving into a far more resilient approach, the state machine. Picture this. It's 2 a.m. Your absolute best customer's credit card suddenly fails. Your system sees that failed payment, immediately flashes a red alert, and literally locks their entire team out of the product. All their vital project data just disappears behind a disabled UI. So when your support team wakes up a few hours later, they're greeted by a furious cancellation request. But here's the massive takeaway. A failed payment does not equal a lost customer, or, well, at least it shouldn't. Treating your billing architecture like a simple Boolean switch is a massive and, frankly, dangerous oversight. Paid equals access, unpaid equals zero access. It just doesn't work in the real world. As our source material bluntly points out, cancel doesn't mean what you think it means. We really need to unpack that. Section 1. The binary billing trap. A lot of startups begin with a pretty basic workflow. Every single request checks the subscription status, and if you aren't perfectly active, you hit a hard block. But SaaS billing is so much messier than just asking if money arrived today. You've got bank delays, expired cards, webhook retries, manual invoices, enterprise overrides, the list goes on. When you treat all of those nuanced situations as a single binary unpaid state, the real-world consequences are absolutely brutal. Customers lose their data unexpectedly. Your support tickets explode with confused, angry users, churn skyrockets, and worst of all, recovering that account becomes nearly impossible because you've essentially punished them over something as minor as an expired card. Moving on to Section 2, Payment Status versus Permissions. Okay, so here's the deeper architectural flaw we need to talk about. Traditional binary systems fail because they tightly couple the collection of money directly to product access. Let's pit these two against each other for a second. On one side, you have payment status. That answers a very simple question. Did the billing provider actually collect the money? On the other side, you have access control, which asks, what is this user actually allowed to do inside the product right now? Yes, they're related, but they should never be the exact same thing. And this brings us to a really fundamental misunderstanding. Billing state does not equal your data life cycle. It is a crazy huge mistake to think that a failed payment should instantly trigger destructive data events. Think about it. A late webhook or a pending card retry should never mean your customer can't log in to export their hard-earned data. When you tie these systems together, it's not just a little billing bug, it's a serious architectural risk that turns tiny payment hiccups into massive, full-blown product outages. Section 3. The subscription state machine. So how do we actually fix this? Instead of asking if a customer is simply paid or unpaid, we need a system that asks what state is this account currently in. We're tossing out that binary toggle and replacing it with a robust 5-state lifecycle. A failing account shouldn't just fall off a cliff. It needs to sequentially progress through explicit states: active, past due, canceled, unpaid, and finally expired. Let's quickly break each of these down so you can see how they protect your revenue. State 1 is active. No surprises here. The customer paid successfully, all their features are enabled, entitlements are granted, usage limits are fully unlocked, and they have complete access. This is the happy path we all want to stay on. But here is where it gets interesting. State 2 is past due. This acts as an absolutely crucial grace period. When a payment fails, we don't just slam the door in their face. Instead, their access temporarily continues. Dunning emails get sent, in-app billing banners gently remind the user to update their card, and retry logic hums along the background. This one simple state saves so many customers who just have a bank limit issue. You're giving the business breathing room to recover that revenue without creating a hostile user experience. Then we hit stage 3, canceled. And man, this is the one most early systems get completely wrong. Canceled does not mean you delete everything immediately. In a properly built state machine, it moves the tenant into a read-only, free placeholder state. Sure, you remove their paid entitlements, but their data is safely preserved. Why? Because returning customers shouldn't feel punished. You want to leave that door wide open for them to easily upgrade and come right back. If they still don't fix their payment, we enter state 4, unpaid. The grace period has officially expired and the retry logic has failed. Now their real restrictions kick in. Premium access is completely revoked and a retention countdown actually begins. But notice what's crucial here. Their workspace still exists. because again, your billing state is not your data lifecycle. Finally, we reach state 5, expired. The retention window is officially over. This right here is the actual end state. Only now do your cleanup policies finally activate, things like archival, soft deletion, and actual entitlement teardown. See the difference? It's a highly structured, totally predictable end, rather than the chaotic 2 a.m. lockout. Section 4, event-driven billing architecture. Okay, so how do we actually wire these transitions up in a real production environment? Well, the most important architectural rule you can follow is this. Webhooks are the source of truth, not your front-end success pages. You cannot, under any circumstances, rely on optimistic updates from a user's browser. Webhook events coming from your billing provider must be the absolute undeniable source of truth to drive every single state transition. But hold on. Your application shouldn't be making critical access decisions directly inside that initial webhook request. Look at this strict pipeline. You receive the webhook, verify the signature for security, store the raw event, and then push it to a queue to be processed by an independent worker. This strict, replace-safe pipeline is absolutely required because, let's face it, webhooks aren't perfect. They arrive late, they arrive out of order, or they hit your server multiple times. Processing them this way prevents duplicate transitions and race conditions from wrecking your database. And because every single state transition is safely handled by that back-end worker, your entitlement engine can actually do its job properly. It never blindly trusts some cached billing flag. Instead, for every single protected action, it checks the current subscription state, the tenant entitlements, plan capabilities, and specific feature gates in real time. It's safe and it's reliable. So, bringing it all together, the core mantra is this powerful separation. Subscription state is tracked meticulously via webhooks, while access state is derived dynamically from entitlements. I really want you to take this away with you today. Intentionally separating these two things is exactly what prevents tiny little billing errors from cascading into massive, platform-wide product outages. Which brings us to the ultimate question for you to consider as we wrap up this explainer. Is your billing system a simple toggle or a resilient state machine? I highly encourage you to go take a look at your own codebase today before another late-night failed payment needlessly locks out your absolute best customer. Thank you so much for joining me today, and keep building better systems.